what are the two different types of intermolecular hydrogen bonding? Hydrogen bonding between same type of molecules and hydrogen bonding between different types of molecules. Okay, hydrogen bonding between different types of molecules. Whatever the hydrogen bond, you have a receptor and a donor, right? You have a receptor molecule and you have a donor molecule. What do you mean by hydrogen bonding between same type of molecule? Hydrogen is attached with one of the most electronegative elements, fluorine, oxygen and nitrogen. Fluorine, oxygen and nitrogen. Hydrogen is attached with one of the most electronegative atoms. Okay, these are the three highest electronegative atoms in the periodic table. Okay, so hydrogen atom is attached with one of the most electronegative atom and one of the most electronegative atom attached again with hydrogen atom. Okay, so assume this hydrogen atom is the receptor. This is the receptor. Okay, always hydrogen atom is the receptor. Receptor means it receives electrons. Okay, and fluorine, oxygen, nitrogen, they are donor atoms. So receptor, which means hydrogen atom, is attached with one of the most electronegative element, and donor is attached with hydrogen. Then it is hydrogen bonding between same type of molecules. So you can produce hydrogen bonds between hydrogen and fluorine. You can produce hydrogen bonds between hydrogen and oxygen. You can produce hydrogen bonds between nitrogen and hydrogen. For example, between HF molecules, you have this type of hydrogen bond, and between water molecules, you have this type of hydrogen bond. Between NH3 molecule, you have this type of hydrogen bond. Here you have a fractional positive charge. Here you have a fractional positive charge, delta positive. Here you have fractional positive charge, and here you have fractional negative charge. Here you have fractional positive charge, and here you have fractional negative charge. Okay. So why? Because fluorine is more electronegative than hydrogen. So pair of electrons are attracted towards the fluorine atom, right? Pair of electrons is attracted towards the fluorine atom. Here pair of electrons is attracted towards the more electronegative oxygen atom, right? So you have fractional positive charge on hydrogen atom. Okay. So why hydrogen is special? Okay, why hydrogen is special? Why you call that as hydrogen bond or hydrogen bonding? Obviously because hydrogen is participated. Okay, but still why it is called as hydrogen bonding? Why hydrogen is special? Because hydrogen is the smallest atom in the periodic table. Okay. Hydrogen is the smallest atom in the periodic table. Then your fractional positive charge is highly concentrated into a small atom, so you have greater charge density. Okay, so charge density of the atom, okay, determines the strength of electrostatic attraction force. All these are electrostatic attraction forces, which means attraction forces between oppositely charged species. Okay, attraction forces between oppositely charged species. So here, all these are electrostatic attraction forces. Strength of the electrostatic attraction force determines by the fractional positive charge. Okay, fractional positive charge. So you have a greater charge density or surface charge density on hydrogen atom because hydrogen is the smallest and the fractional positive charge is highly concentrated. Okay, the fractional positive charge is highly concentrated. So that's why hydrogen atom is special, because it can produce stronger dipole-dipole interaction, and that stronger type of dipole-dipole interaction is known as hydrogen bonding. So this is the story behind the hydrogen bonding. So my point is, why chlorine ignore in hydrogen bonding? Because fluorine, oxygen and nitrogen are period 2 elements. Okay, fluorine, oxygen and nitrogen, they are period 2 elements, and chlorine is a period 3 element, and it is larger. Then what happens? The fractional negative charge you get on chlorine atom spreads because it's a larger atom. Okay, because period 3 element. Fluorine, oxygen, nitrogen, they are period 2 elements, so small atoms. There is no spreading the negative charge like in chlorine atom. So even you have identical electronegativity for chlorine and nitrogen, you ignore chlorine atom because chlorine is a large atom. You have lesser surface charge density. Okay, you have lesser surface charge density. So this is the reason to ignore chlorine atom. So hydrogen bonding between same type of molecules means hydrogen, that is receptor, is attached with one of the most electronegative atom like fluorine, oxygen and nitrogen. In other hand, the donor atom also attached with hydrogen. Okay, also attached with hydrogen. Right. So what do you mean by hydrogen bonding between different types of molecules? So there are 2 examples. Okay, there are 2 examples. Hydrogen bonding between different types of molecules. There are 2 examples. First one, your receptor. Okay, your receptor is attached with one of the most electronegative atom. Okay, your receptor, that is hydrogen, is attached with one of the most electronegative atom, like hydrogen is attached with fluorine, hydrogen is attached with oxygen, hydrogen is attached with nitrogen. Likewise, here also hydrogen is attached with one of the most electronegative oxygen atom. Okay, one of the most electronegative atom, that is oxygen. For example, oxygen. So methanol, right? Example like a methanol. Okay. So hydrogen, here hydrogen is attached with one of the most electronegative element. That means your receptor is attached with one of the most electronegative element. But your donor is not attached with hydrogen. Your donor is not attached with hydrogen. For example, double bonded oxygen atom. Okay, double bonded oxygen atom. For example, this is what you call as acetone. Okay, this is what you call as acetone. So in acetone and methanol, you have hydrogen bonding. Between acetone means it's a solvent. Okay, so acetone, in acetone you have double bonded oxygen atom to carbon. Okay, you have double bonded oxygen atom to carbon, that is acetone. So between acetone and methanol, which means this and this, between these molecules you have hydrogen bonding between different types of molecules. What do you mean by different types of molecules? Here, hydrogen atom, that is what we call as receptor. Hydrogen atom, why it is receptor? Because it cannot act as a donor. What do you mean by donor? It donates pair of electrons. Donor can donate pair of electrons. But hydrogen never donate pair of electrons because you don't have non-bonding electron pair on hydrogen atom. So hydrogen always receptor because it can donate pair of electrons. So here also hydrogen is the receptor and it is attached with one of the most electronegative oxygen atom. Here same hydrogen is attached with one of the most electronegative atom. So receptor is attached with one of the most electronegative atom. Here donor is attached with hydrogen, but here donor is not attached with hydrogen, it is attached with another atom, carbon. Okay, so oxygen is attached with carbon and here you have a multiple bond. You need a, without having multiple bond, you cannot have a hydrogen bonding. Why? Say you have another molecule, oxygen, carbon. Okay, you have another molecule, oxygen attached with two carbon atoms, but they are single bonds. Okay, they are single bonds. Here, this oxygen atom cannot produce hydrogen bonding because it is single bonded. Single bonded oxygen atom cannot participate for hydrogen bonding. Okay, single bonded to carbon. If it is single bonded to hydrogen, then it's okay. It can participate for hydrogen bonding. But if oxygen, whatever one of the most electronegative element like nitrogen, oxygen. So if oxygen or nitrogen is single bonded with another atoms, then it cannot participate for hydrogen bonding. Definitely, you need multiple bonded oxygen atom. I mean double bonded to carbon. You need that. Why? Because in a double bond, you have a sigma bond and a phi bond. Okay. So what is the difference between sigma bond and phi bond? So what do you mean by sigma bond? You have the electron cloud, right? You have the electron cloud on the line joining axis of two nucleuses. You have the electron cloud on the line joining axis of two nucleuses. Okay. So that's why it is stronger, because when you have electron cloud in between two nucleuses, right? Exactly in between two nucleuses. So this is your nucleus and this is your other nucleus and this is your line joining axis. The red one is line joining axis. Then what happens? You have stronger attraction forces because your electron cloud is exactly in between two nucleuses. Then you have stronger attraction forces. So sigma bond is a stronger bond. If there is a one bond, right? If there is a one bond, definitely it's a sigma bond. Okay. If there is a single bond, definitely it's a sigma bond. Single bond not sigma bond. Single bond not sigma bond. Single bond not sigma bond. So what happens? If the electron cloud is in between the line joining, if the electron cloud is on the line joining axis of two nucleuses, then what happens? It is hard to polarize. What do you mean by polarize? What do you mean by polarization? You have the electron cloud and there is a distortion of the electron cloud. Okay, there is a distortion of the electron cloud. If the electron cloud on the line joining axis of two nucleuses, that means electron cloud is exactly in between nucleuses. So it is hard to polarize. Okay, but still, if the electron cloud on the parallel axis, if the electron cloud on the parallel axes, if the electron cloud is on the parallel axes, then you have lesser attraction force to the electrons present in the poielectron cloud. Lesser attraction. When you have lesser attraction, right? Then it is easy to polarize. Even for an external species, it can easy to polarize. electron cloud. For electron cloud is easy to polarize. Okay, it is easy to polarize. So here, between carbon and oxygen, you have a double bond. You have a double bond means one is a sigma, the other one is pi. Okay, you have a double bond means one is a sigma bond and the other one is a phi bond. So you have a multiple bond means you have easily polarizable phi electron cloud. When you have easily polarizable pi electron cloud, then you have greater electron density on oxygen atom, because it is easy to polarize the electron cloud towards oxygen atom. Okay, because oxygen is more electronegative, oxygen is more electronegative, and here you have phi electron cloud. Phi electron cloud is easily polarizable. So when you have phi electron cloud, it is easy to polarize. It is easy to polarize the electron cloud towards the oxygen atom. Okay, so there is a greater polarization in the phi electron cloud of carbon oxygen double bond. There is a greater polarization of the phi electron cloud of carbon oxygen double bond. Okay, so you have a greater fractional negative charge on oxygen atom. But here it is different. Okay, but here it is different. Carbon oxygen sigma bond, you have a sigma bond. It is hard to polarize. So you have lesser fractional negative charge on oxygen atom. You have relatively a lesser fractional negative charge on oxygen atom. So you never produce hydrogen bonds between oxygen atom and hydrogen atom, single bonded oxygen atom, like single bonded oxygen atom, which means oxygen is attached with two other carbon atoms, right? It can be attached with hydrogen. If it is attached with hydrogen, you have hydrogen bonding. But if oxygen is attached with two carbon atoms, you never have hydrogen bonding. But here you have hydrogen bonding because oxygen is multiple bonded with carbon. Okay, oxygen is multiple bonded with carbon. Actually, what is the requirement? Okay, what is the requirement for hydrogen bonding? You need hydrogen atom. Okay, you need hydrogen atom. Why hydrogen is special? Why hydrogen is special? Because you have greater fractional positive charge on hydrogen atom. Why you have greater fractional positive charge on hydrogen atom? Why you have greater fractional positive charge on hydrogen atom? Because it is smaller. Not only that, it is attached with one of the most electronegative. So what is the requirement for hydrogen bonding? If you ignore that it is hydrogen, ignore the concept, right? Ignore that is hydrogen. What is the basic concept? What is the basic requirement? Having a stronger dipole-dipole interaction. So when you have greater fractional positive, why you have greater fractional positive charge? So why you have greater fractional positive charge here? Because fluorine is the highest electronegative element. It attracts electrons along, okay, or else it withdraw electrons, okay. It withdraw electrons through hydrogen fluorine bond. It withdraw electrons through hydrogen fluorine bond. So you have greater fractional positive charge. And here also you have greater fractional positive charge because oxygen more electronegative and it withdraw electrons through hydrogen oxygen bond. Okay, so here also you have hydrogen bonding. Why? Because you have greater fractional positive charge. Why you have greater fractional positive charge? Because carbon strongly attract electrons from hydrogen atom. Okay, carbon strongly attract electrons from hydrogen atom. Why carbon attract electrons in CH1? Because there are three chlorine atoms. This is chloroform. Okay, this is what we call as chloroform. In chloroform, you have three chlorine atoms. you have 3 chlorine atoms, and 3 chlorine atoms withdraw electrons. 3 chlorine atoms withdraw electrons. Because of that, you have greater electron deficiency on carbon atom. What do you mean by electron deficiency? That means you have lesser electron density. Okay, lesser electron density. So 3 chlorine atoms withdraw electrons through carbon halogen bond or carbon chlorine bond. So you have greater electron deficiency on carbon, Because of that, you have greater fractional positive charge. Okay, you have greater fractional positive charge. So you have greater fractional positive charge. So that is the requirement. Having a greater fractional positive charge and a greater fractional negative charge. That is the summary. Okay, so that is the summary. Requirements and everything. Okay, they are built up based on this one. What is it? Having a greater fractional positive charge and fractional negative charge. So what is the requirement for stronger dipole-dipole interaction having a greater fractional positive charge and greater fractional negative charge? Among all the dipole-dipole interactions, okay, dipole-dipole interactions associated with hydrogen atoms are classified. Okay, stronger dipole-dipole interactions associated with hydrogen atoms are classified as hydrogen bonding. So what is the requirement for hydrogen bonding? Finally, that is the summary. What is the requirement for hydrogen bonding? Definitely you need hydrogen atom, and we should have a greater fractional positive charge on hydrogen atom. You need a greater fractional positive charge on hydrogen atom. That is the requirement. It is not the requirement there is hydrogen attached with fluorine, oxygen, nitrogen. ඕක තමයි hydrogen bonding කියලා ඔයාලා දන්නේ. ගොඩාක් අය දන්නේ ඕක තමයි. and මම නම් මේවා හොඳටම කතා කරලා ඔයාලට කියලා දීලා තියෙනවා. still අමතක ඇති ප්‍රශ්නයක් නැහැ. ඒ නිසා තමයි රිවයිස් කරලා දෙන්නේ. අමතක ඇති මේ නොකලාසේ කරනවා. නොකලාසේ කරනවා. right පැහැදිලි නේද කතාව? right. So finally that's the requirement, having a greater fractional positive charge. In other hand, make mama explain kara, here oxygen is not attached with hydrogen. So enang again make a lesson to classify, so you can understand like it is like 3 types but still only 2 types. Okay, because hydrogen bonding between same type of molecules, hydrogen bonding between different types of molecules. Again, there are 2 different types of molecules. Okay, there are 2 different types of molecules. One is receptor is attached with one of the most electronegative element, but the donor is attached with donor is not attached with hydrogen. Here, hydrogen is associated with both parts, I mean the receptor molecule and the donor molecule, right? Both are affected by hydrogen atom. Okay, donor molecule and the receptor molecule, both donor molecule and the receptor molecule are affected by hydrogen atom. But here, only receptor molecule is affected by hydrogen atom, but the other one is not affected by the hydrogen atom. And here, neither definitely receptor kan right, associate receptor, but here receptor hydrogen atom is not attached with one of the most electronegative element. Okay, so ඕක තමයි කතාව.